Now, okay. All right, welcome everybody to the July 24th, 2025 edition of the Technical Advisory Council of the Confidential Computing Consortium. We are an open and collaborative community. Everybody on the call is welcome to join in the conversation today, and we appreciate all constructive dialogue here or in any of our open source, collaboratively right. We also abide by the antitrust policy of the Linux Foundation, and you can read more about that on linuxfoundation.org/antitrust-policy. Today, our main topic is the DStack proposal, and we have Shelvin on to present that. So we'll be turning things over to Shelvin in just a few slides. I don't anticipate that we will vote on that today, but we might. And so we'll just kind of keep an eye on what our quorum is like. So if this is your first time at the meeting, this is the list of people who have voting rights, but typically we try to minimize the amount of voting we do and focus on having a consensus across the community. So I'm just going to do a quick look down the roster here. I don't see Nathaniel. Do we have Paul? Paul, thanks for joining today. Catherine, thanks for joining. Do we have Wu Youngjen? Nope. Intel is not represented today. Just as a reminder, I am changing affiliations. I no longer represent Intel, but I continue to chair the meeting. I just don't have a vote when it comes to things like this. Henry or Kevin? Nope. Alec just sent a note that he's unable to join today. And we have Fritz. And Yash sent a note previously that he is out this week. Ming Shen or Dale, I think there should probably just be Ming Shen going forward, right? I think Dale's no longer with TikTok. Just somebody can confirm that for me in the background, but I'm pretty sure that's the case. And then no Bob today. So I think we are short of quorum, but I know that people who were not able to join this morning often watch the recording, or at the very least, they will read through the minutes. Okay, and now is the part of the meeting that if you are relatively new to the community, if you haven't introduced yourself twice, because it kind of takes a couple times usually to get to know people, feel free to come off of mute and let us know how you prefer to be addressed, where you're joining from, and your interest in confidential computing. Well, I think I recognize everybody's name, maybe. Well, if you were unable to get off of mute or you decide later to introduce yourself, you're always welcome to do that. But we will go ahead and move along with the agenda. Quick recap of old business. We discussed the summit last time, I think, and we had the annual review for the Open Enclave SDK by Radhika. And we did maybe just a very brief discussion of the glossary. And Alex's update at the time was about the Cloud Security Alliance, that that glossary was initially a response to a request they made, and he's still looking to get back in touch with them to see if that's something that they have referenced. And that will help guide us on how much we continue to invest in that. We don't have any announcements for today that I'm aware of, but if anybody had something that they didn't get on the agenda, now is the time to speak up. Well,
I just started on something this morning, which I can announce. So Git Jobs is a open source job site that the CNCF has launched, and they are busy rolling it out across different open source projects. And I am working with the open jobs that we have at the moment to transfer them to Get Jobs, and then we're going to change our page so it's self-service for all the members. So if you have that jobs, go to Get Jobs. I'll drop it in the channel. Select CCC as your organization, and it will appear on our webpage as soon as we did the updates.
That's very cool.
How long do you think it'll take to move across, do you think?
I'm moving it across for 5 minutes, but I need the people that have current jobs up just to populate the list. Otherwise, we're going to publish an empty list. So if anybody has a job here, I will roll it out.
And that's another thing. Always, we very much encourage people to put jobs from their companies or the ones they know about. Well, from their companies, yeah, to on the site. It's really good. It's good for us. It's good for you, hopefully. So please consider doing that.
Sounds good. And welcome as well to Jeff. I saw your note in chat just now. Nice to have you in the meeting. All right, at this point, I will turn things over to Sheldon, and we can talk about the DStack proposal. I hope everybody's had a chance to read through what was sent to the mail list so that we can make sure that we can jump into the things that people have questions about. But I know Sheldon's prepared some material to walk us through the project.
Yeah, thank you, Dan. Yeah. Let me share the screen. Yeah. Okay. So yeah, hi everyone. I'm Sheldon Zhou from Follow Network, and I'm the lead researcher. So and I also saw like Andrew Miller here, and also our CTO Hang is here. So they are both the co-contributor to this project. So like if you have any questions during my presentation, please feel free to leave them in the chat. And I think they can help me like answer it. Yeah. So yeah, today I will introduce like our work here. So it's called DStack. It's a zero trust framework for confidential containers. So but just for clarification, so for example, if you search DStack in the GitHub directly, you will see I think the top one is a SDK called DStack AI, and maybe you need to search for DStack TE. You will get the correct project here. Yeah. So okay. I think I will start with a motivation example here. So actually, this is some problem actually we have received from our customers. So I think it's a very typical case of so-called the AI data marketplace. So usually in this case, like there are several parties here. So there is a model owner who who has the base model and but don't want to leak his own model parameters. And also there is a data providers who want to use this base model to train some, for example, use some technical like reinforcement learning to train a better model for him to use. And the data provider, he will usually come with a data set to do the training. And usually so since both parties, they do not want to leak their own like privacy. So usually T is chosen in this case as the black box execution environment to do the training. So to ensure like both of the model parameters and also the data set cannot be seen by both parties. So here there is some requirements. So first, like the model parameters must be remain confidential to the data provider, and also the training data must be remain like confidential to the model owner. And I think the third part is a very important part because actually both parties, they want such guarantees to be verifiable. So they can ensure that, okay, my data or my model parameters is really being protected. Yeah. Yeah. I think a major difference here compared with the traditional like use case is about the threat model, especially like the model owners who usually is the developers or like the administrator of the application. In this case, actually, he is regarded as not trusted. because from the data provider's point of view, actually these developers, he may try everything. For example, he may try to write some backdoors, or like he may try to update the code to a malicious version to try to dump the data. So that's why the model owner here in this case is not trusted. And also, based on the feedbacks we collect from our customers, actually, many of them, they know the first question they will ask in this case is about the TE vulnerabilities. So yeah, so like they were asked about, okay, so whether there will be a hardware attack or how you will handle the side channel attacks. So everything. So people has concern about the TE vulnerabilities. They do not trust TE for no reason. Yeah. And the third thing here is that we must regard the risk of the single point of failure, because even if the TE hardware is not compromised, actually it can going down. So this means, for example, all these things, if the training is not finished on time, then this means all these runtime states or like the data can be frozen if that TE hardware is down. Yeah. So what are missing in the current TE solutions is that, so first it's about the verifiability, because actually given the current like remote attestation reports, it's very hard for both parties, especially for the data providers, to learn about the details of the source code, like what kind of application he is really interacting with. And the second is about the robust key management case, because usually, actually, we have inconsistent key management policy across different key implementations. Yeah, I will cover it later. For example, SGX, it will rely on the hardware-bound keys, and the solutions like TDX, it just didn't come with any default key management service. Yeah. And the third part is the continuous security assurance. So it's more about the service availability and the data availability. So how we can ensure that, okay, so this training can be finished, even if like a certainty hardware is down. Yeah. So I want to elaborate a bit on the real problem here. So the first is about the TE vulnerabilities and also the concern about like the data availability problem. So this is usually come from the limitations of TE. So because just as I show in this table, so different TE solutions, it has different key management service and status, sorry. And also, like, since there is inconsistent key management across different TE technologies, so actually, it's kind of hard for the developers to have a consistent experience if they are using different TE solutions. Yeah, and also usually currently, if the TE is shut down, this usually directly means the loss of the data. So, and unfortunately now we do not have like some cross hardware a recovery mechanism to help us to restore the execution if a TE node is down. Yeah. So and from our side, I think so. The major the key to the recovery problem here is that it's about the key management, because actually to back up encrypted data is very simple. So I think there is a lot of solutions that can doing that. But even if the data itself is backed up, so we still need to take care of the keys, the encryption keys that the TE can use to decrypt this data. So the things we really need here is that it's a secure key recovery mechanism which is independent of specific hardware. So like we can know even if a certain TE node is down, we can still always ensure, okay, the key is there. So we can always launch another TE hardware to restore the execution. So we can share the key to it so it can decrypt the data again and to restore the states. But this is one of the problem of the current TE is that actually since there is no consistent solutions, so this introduce some extra costs for the developers. So usually when we talk actually at the early stage, when we talk to our customers, okay, you will need to do this backup, you need to do the key management, you will need to handle the data migration yourself, and then okay, they hesitate to use the TE. Yeah, and the second is the limited verifiability. So in the right, I show a very typical attestation report generated from the Intel TDX. So actually, you can see there is a lot of I would say hash values there. But actually, if I'm a user, or actually, I can learn nothing from this report. So, for example, is this really from the application I'm interacting with, or like it's just generated from another T application and forwarded to me? And second is that actually it provides no information about the source code, so I can not know whether there's backdoors or whether my data is being correctly handled in this way. And yeah, so this is the problem. So actually, for the technical part, so the attestation report provides verifiability, but actually from user perspective, actually he cannot learn the most important information from the report. So this is another problem for the current TE part, is that actually by using the TE, it brings no direct benefits to the developers, because actually their users is all the security and verifiability provided by the TE is not perceivable by their users. So this is another problem. Okay. So and this is the final one. So why we like set the developers as untrusted in our trust model here is that we can consider such a very simple, like I would say it's a tag here. So for example, actually this is something that happens already to the in the blockchain world, to the smart contract. And the similar things we also observe to the TE apps here is that at the beginning, the developers, he may release a benign app. Maybe he will just open source or even has the code audited. And the user, they can see everything. So they will be very confident about this. But for example, if we allow the users to, if we trust the developers in this way, then this means the developers can do a stealthy update of the application to replace it to a malicious application. So in this way, he can really steal everything from the users. And I think I skip one step here, is that actually, if we do not have something like a transparency log of the application lifecycle, this means the attackers, he can just update the application again and replace it back to the benign application. So in this way, no one will know what happens during these like app updates. Yeah. So I think this is a very important point here, is that, for example, if we allow the administrator to update the code without being noticed, then all these protection from the TEs will become meaningless. Yeah, so this is why the I think such transparency log is very necessary in this case. Yeah, so here is a very simple summary of all the things I have covered. So there's many technical challenges here, including the TE vulnerabilities, the risk of single point of failure, and also the lack of application lifecycle control, and also the limited verifiability with the current attestation report. So what we want to do is so-called a zero trust platform, which solve all these challenges. So this means, for example, we need some workaround. I would not say we can totally like eliminate all these attacks interface in this T is impossible, but at least we need some workaround. For example, if some attack is really happen, we need to ensure, okay, the application, it can resume execution, so even after being attacked. And second is that we want to bring the data and service availability to the TE application. And the third, we need a way to enforce the principle of code is law. So this includes that, okay, so first the application code itself need to be audited, and also like all these following updates of the code need to follow the I will say the agreement between the developers and the users. Yeah. And finally, we want to build a fully verifiable chain of trust, which can allow the user to verify both the hardware, the source code, so everything they're interacting with. Yeah. And apart from these benefits, I think cost is also another very important fact we take into consideration. Because previously we have some talks with our customers, many of them they are developers. So we just ask them, so why don't you use TE? So even if like we try to just provide the same price compared with normal hardware. So first, yeah, they have concern about vulnerabilities and the vendor lock-in if they use certain TE. And second is that they do not want to rewrite code. This is very typical in the previous case of Intel SGX, because you need to like change your code, or at least use something like libOS to reassemble your binary. So this is some extra efforts. So the third concern is about performance limitations and overhead. And the last part, I have covered that. So the T is invisible to their customers. So the major reason why, at least at the beginning, they try to use TE, but finally they choose to just claim that, okay, they have a plan to use TE in the future. Yeah. So this is also the things we need to take into consideration. We want to ensure all these benefits we have promised before can come with very low cost. Yeah. Yeah, so this is what DStack tries to provide. So I think the innovations from DStack can be majorly divided into three parts. So the first is we implemented a feature called portable confidential containers. So usually we use a independent key management service to support that. And with this means all these stateful confidential virtual machine, they can be migrated between different TE instances. Now we only support Intel TDX, but actually, so we have the plan to support the TE solutions from the other vendors. So, and now we have already done some migration between different Intel TDX servers, but in the future, I think it will be possible to migrate between TE hardware from different vendors. So, and second part is something called is the co-management with distributed ledgers. So in short, we use we implement a default like governance mechanism with smart contracts. So this means all these code updates, so all these critical actions on the code life cycle, it must be initiated from smart contract, and they have to be like audited. For example, they have to pass the multi-sig. So multi-parties need to agree on this, and finally this code updates will take effect. And also the distributed ledger will be a very perfect place to act as a transparency log to record all these code changes. Yeah. And the third part is the full chain of trust. So apart from the source code verifiability, we also implement a protocol called Zero Trust HTTPS. So in short, with this means a domain can be exclusively controlled by the TE. So in this way, actually, by visit a certain URL, then the users we can ensure that, okay, this user, he is really interacting with the TE app behind that URL, who is controlling that domain. Yeah, and also currently we just support Intel TDX, but also we support TE GPU from NVIDIA. So it's the H100 and H200. So yeah, so and also we have planned to support more hardware in the future. Yeah, so then I will have a simple introduction to each innovation. So yeah, so for to support the portable confidential containers, the key here is that we generated the secret key with an independent key management service. So yeah, so as I said, so previously, for example, in the SGX, I think that the right figures. So this is a very typical case when you try to generate a key in the SGX. Is that actually the SGX is no matter you are try to generate a attestation key, or you are using a data stealing key to encrypt your data to the hard disk, actually these keys are coming from some hardware based key, which is wired in the CPU. So this is the problem, because if you encrypt it with this hardware-based key, then this means if this key is down, then no other hardware in the world will be able to decrypt it. So that's why we have to replace this with something with an independent KMS here. Yeah, and here, actually in our case, we provide a standard interface for the KMS. So you can see here, so it's just includes to generate some keys for certain application given the metadata, and also it will need to generate the key to encrypt the environment values we pass to this application. And also there is something like called also each KMS should be equipped with a certificate, a standard X509 certificate. So this certificate can be used to build a chain of certs to prove the source of these keys, where it's come from. So yeah, And actually, all our partners, everyone who try to use the DStack, he can choose to implement the KMS himself following this standard. But also, we are by default we provide a P2P TE network. So each TE they act is a KMS node, and they act as a duplicates to each other. And this is controlled by the smart contract. So in this way, like the smart contract, it contains the valid code hash, the KMS digest of a valid KMS code, and so then all these TE will run that code. So yeah, people can choose to interact with these KMS to get the keys. Yeah, and second is a decentralized code management. So still we will use the smart contract to record all these code lifecycle changes. Yeah, but this part is also customizable. Yeah, and for example, if we have after we have these like code management, then the life cycle for developers to update his code will look like. So first, he needs to submit the new code hash to the smart contract and wait for the approval. So such approval can be programmably specified. For example, it can be a multi-signature. So after like M of n people has approved it. Okay, so this update request will be passed, and only if this is approved, then the DStack KMS smart contract will tell the KMS node to generate the keys, to share the keys to new code. So only in this way, the new code will be able to decrypt the old data and do the execution. So in this way, by using the KMS, we can enforce. Okay, so so only this approved code will be able to decrypt the data. Yeah. So the third part is the verifiable domain management. So we implement it to enable the TE to exclusively control a domain. So actually, it can be generally divided into two parts. So the first is to, I think it's quite trivial, is that we can use the TE control keys as the private key to generate a certificate. So, and to bind it to a certain domain. This is quite simple. But the things really hard here is that how to ensure that, okay, so this TE control domain cannot be changed, because usually it will rely on some external services which is not in the TE. So usually, for example, we will rely on the DNS services like Let's Encrypt to do the things. So as a human being, I can totally just try to reclaim the account and just replace the certificate in this way to get it back. So actually, we cannot prevent that. But what we do is that we can have a monitoring service there. So with the DNS CAA records and also the transparency log services, it's a certificate transparency log, which is which we can always know like the certificate assurance history of a certain domain. So so with these things, we can do the monitoring of the ownership of the domain to ensure that it's only controlled by the TE and never being acquired by any human beings outside that TE. So yeah, and actually in practice, we will try to ensure each domain we use has a clean history. This means it was never controlled by any other service before, so it's only controlled by the TEs. So yeah, so this is an example. So you can see like so all these things is just from the same issuer. So and if you further check the CAA record, you can know, okay, it's from some certificate which is really controlled by the TE. Yeah, and the last thing we build upon that is interactive UI, so to help the users to know what's really happening. So I can have a live demo in this case. Yeah, yeah. Can you see it?
No, it's very small. Can you make it larger?
Oh, yeah. Okay. Oh, too large. So it's better.
That works for me. I can always
Yeah,
zoom
it's not-
things independently on my
Yeah.
screen.
Yeah, so with this, so first now, actually, so it's still in beta, but in the future, like every apps who is using the DStack will be able to generate such kind of UI to prove to the users. And actually, it contains like several parts of the verification report here. So first, it's about the hardware. So usually, it's a TE CPU with the model information. And also it's about the source code. So the third part is about since the domain is controlled by the gateway. So actually we can ensure the network is end-to-end encrypted. So also like in the TDX case, so everything we run in the TDX is a complete image consists of both the application and also the operating system. And the operating system is an image from the DStack official. Yeah, so it's built by the reproducible build, so people can check. So we can also, apart from the application itself, the operating system itself can be verified. So last is the key management service is used. So I think we can try to walk through this a bit. So in this case, we usually we always start with the attestation reports. So this is since this is signed by the Intel, so and generated by the hardware, so this is very easy to verify, and it contains some. I think these are the meaningful values. So the MRT register, the RTMR 0, 1, 2, 3 register. So these are the measurement register, which measures both the operating system, the hardware, and also the applications source code. And
Gavin, your voice is breaking up.
I think it's a bandwidth problem. I will.
Maybe you need to
Try turning off video.
Yeah. Doing that. Oops. Yeah, is it better?
Yeah, it's good.
Yeah.
Okay, cool. So yeah, and so yeah, continue about the measurement register. So actually, in this way, like register 0, 1, 2, 1, and 2, RTMR 0, RTMR 1, RTMR 2. So these registers they are built in by the Linux kernel directly. So actually, we do not customize their value. I think the things we do here is that we really customize the RTMR3 register. Actually, this is I think this is the recommended practice from the Intel. We can use these things to generate some application-specific events, so to help to do the verification. So we write something here. So like the compose hash. So we will use these to trace back to the Docker compose file we are using to run this application. And also there is something else like so this is the encoded identity of the KMS. So actually, we have some way to, based on this value, we can trace back to the KMS sys running. So this is also like the OS image hash. So everything here, but we can just concentrate on this compose hash here. So and by knowing this valid compose hash, we can trace back to the application information here. So in our case, like every application, it has the smart contract as the governance contracts to control what is the valid code that can be run for the application. So this means actually I can go to this smart contract and check the historical event here. So actually this is the limitation for the smart contract. But with this, I can say, okay, so this is the value of a valid compose hash. So only the Docker compose file of this hash is considered valid as the source code of the like application. So then with this compose hash, we can further go back to the information of application code. So in this way, since I'm running a Docker compose file directly, so it's actually there is no source code here, but based on this Docker compose file, you can know that I'm running a like official Jupyter notebook here. Yeah, then please.
I was just curious. So for extending the RTMR3 values, is it the
Yeah.
agent that does that? And if it's
Yes.
the
So
agent, what measures the agent?
yes, actually, so this is part of the OS code. So it's here, app OS. So actually, since we provide the Docker support for this application directly, so from the user's developer part, they just need to submit a Docker compose file to us. So what DStack will do is that it will generate the DStack itself contains some OS image, and it will just assemble the OS image with that the Docker runtime, and then with that the Docker compose file from the users to be a complete image that can be run in the TDS directly. So all these RTMR3 values, the fill-in from RTMR3 is done by the operating system.
Okay, so the operating system, though, you need some code to do the actual measurement. I assume that was the agent that I saw on your architecture slide.
Yes, yes.
And so that
I can
agent,
probably jump here. So, because the operating system itself is also a part of the stack, we do have the source code and also the reproducible build for the operating system. So, including the kernel and also uh the scripts that trigger the other actions after the kernel is booted. And then eventually it runs the agent we deployed into the CVM. And then the agent brings up the user level application running in Docker. So this is a chain of trust from the firmware BIOS to kernel, and then the init script after the kernel is booted, and and then to the agents, and finally the application is fully measured to all the RTMRs.
Yeah.
okay, thank you.
Yeah, I just want to introduce this part. So is that since actually in this case the DStack OS, the operating system, it acts as the cornerstone of the whole system. So it's very important. So that's why. So first, DStack itself is totally open source, and for the DStack OS, we support the reproducible build. That means although we provide the out of box the release artifacts on the GitHub directly, so anyone who wants to verify this part, he can just clone. He can just clone the repo. He can just try to do all these compilation himself locally, and finally he will get the same artifacts just as we publish on the GitHub release. And also to ensure all these code logic, all these things in the DStack OS is consistent to the expectation. We just finished audit of the DStack SDK, and the major focus is on the DStack OS. Yeah, it covers part of the KMS and gateway logic, but majorly the DStack OS is fully audited. So to ensure like all these measurements generated by the OS is correct. Yeah. Yeah, and during the like audits, yeah, please, if you have any questions.
Yes. I see with Docker and the DStack OS, but would that work in Kubernetes like kata containers, or is that something that you going through because Docker Compose and VMs are kind of not what the enterprise are using today. They're using Kubernetes.
Yeah. Yeah, I think this is a very good question. Actually, I think I will talk about this later, especially in the comparison between the DStack and also another SDK called confidential containers, Coco. So Coco provides Kubernetes support, and also the support for the Kubernetes is on our roadmap. We already have some design, because compare with Docker, actually Kubernetes itself is highly dynamic. So it's kind of hard to control what people can deploy. Like for example, they may run another pods. They may run multiple pods instance every time. So this means it's kind of different model from the the Docker case. But yeah, we have this plan, and also we have a simple like design document to ensure. Okay, so to make the dynamic management of this pod a little static, so we can generate some valid attestation report on it. Yeah.
Thank you. And it's very interesting. Contact me or send your contact so I can get in touch with you.
Yeah, sure. Yeah, thank you. Yeah, I just want to let you know, like all these, we will publish this. I'm not sure whether we have published it or not, but yeah, it's ready, and we have fixed all these issues these guys found during the audit process. Yeah. Second things I want to introduce here is that actually, since AI is a very important direction we try to explore, so we want to bring these GPUs to the AI world, to the LLM. So actually, we run a benchmark very early, late last year, to try to benchmark those open source LLM on the TE GPU. And at that time, so I think due to the driver problem. So at that time, it's only supports like 1 T CPU plus 1 T GPU. And now, recently with the driver update, there is already a PPCIe model support in the NVIDIA GPU. So now this means we can have like one CPU with like 8 graphic cards. So this means actually now from the capability or performance perspective, so the T stack is totally comparable with the non-T version. Yeah, and with our previous experiments, we find that the performance overhead is majorly come from the data transfer. So between the CPU and GPU, because it involves some encryption and decryption process. And for most of the LLM queries, the overhead is below like 7%. And for larger models and longer sequence, which means like, for example, if we set up the LLM correctly, so with some warm up, so this means it will bring nearly zero overhead. So I think this was a very promising result after we have done that. And and now actually we have already run some models as a service inside TE GPU and provided as a service for the customers. Yeah. And finally, this is usage statistic. So this is published on Dune. So actually, it's live data. You can always check there. So now we have like over 1,000 running VMs, which all use this stack. You will see a drop here. This is because last week we just removed some spamming accounts there. Yeah, but yeah, so I think this is very promising number here. So and it's keep increasing. We keep receiving requests from other partners. Yeah. Yeah. Finally, this is the project status. So Fala Network and also the Professor Andrew Miller here. So we are the core contributors to the project, and also we have some partners like the Near AI. So they focus more on the AI part. So they do a second round development over the DStack and wrap it into something called private ML SDK. And also we have other guys from the Flashbots as the contributors to the project. Yeah. Yeah. Finally, I will talk about some future plan here. So first, just as Pierre has said, so now it's just Docker support. I think the Docker support is good for many individual developers, but not good for a big enterprise. So we are already considering the Kubernetes support. And also we want to ensure there is a high availability and it's equipped with end-to-end encrypted network between different pods. So second is about compatibility. So we have we want to support more hardware apart from the Intel TDX. And we want technically also only if it's a virtual machine level TE solution, we can support that. So it will not involve big changes to the things. So the third part is about the security. So now the KMS is simply like a P2P network, which each node just act as a backup for the others. But I think a good practice here is to combine the multi-party computation with TE. So in this case, it will be harder to compromise the KMS because you need to compromise the majority of the nodes. Yeah. And also we so although we have the workaround with the portable confidential container, so the detection of the T attacks is also a big problem. And to be honest, we do not have very good ideas in this part. I think the only achievable things we can hear is that we can put some honeypots there. So to try to help detect the attacks. And for example, if some honeypot is attacked, we can take something like we can rotate all these keys in the KMS, or we try to check all these T hardware with vulnerabilities in network and try to patch them. Yeah. So the last part is about sandboxing, because I think this is not a big problem, but we have talked with some customers with AI, so sandboxing is also something they're very of concern too. Yeah, I think before my end, I want to add this because yeah, I think Dan asked for this so yeah, before the meeting. So now there is not much SDKs that's for confidential containers. We have a lot of things for like low-level SDKs for the like SGX and other solutions. But I think to really talk about the SDKs for confidential containers, there are just DStack and the Coco. So from my point of view, so these two projects, we share the similar security design principle. So for example, in the Coco, you can also see that they implement an independent KMS to manage the secret keys for running the workers. But since they support Kubernetes, the key management is for like pods in their case. But I think the major difference is two sides. So the first is that we have different requirements on the verifiability. So in our case, verifiability is one of the core requirements when we are designing the DStack. And the second is about usability. So for our side, we want to ensure all these developers, so who maybe he is just a developers who never touched TE before, but we want to ensure that he can very easily get this running inside the TE with all these best security practice. So, but I think the Coco, they adopt a different approach. So they want to do the minimal things, and they leave a lot of those things to the application developers. So this is why there is some difference here. So for the verifiability things, we support reproducible build for all the DStack components, but Coco do not. And I think we are the only ones who do the code audits on the core components. Yeah, and for our side, we since we want the users to be able to track to the source code, so our measurement target is usually on the Docker compose file. Yeah, and also maybe some source code information. But from the Coco side, actually they do not care about what kind of code is running inside the container. What they do is that they create the sandbox runtime, and they allow the developers to specify a security policy, like what kind of the things these sandbox application can do. So this is the part they are measurement against. So yeah. And the third part is that we can the DStack application, they can always generate attestation on request. We provide the API for them to do so. But for the Coco side, since they are just they want to enforce the security policy, they do not support runtime attestation generations. But usually the attestation is generated only once when they create the sandbox. They want to ensure the sandbox runtime integrity, and also they want to ensure the correct security policy is enforced during setup. Yeah, and then for the rest, yeah, it's all for the ease of use. For example, the native support for encrypted network connection, the native support for encrypted disk support, and like the service like trust center and the transparency log. So yeah, this is why we provide them, because we care about the verifiability and ease of use. Yeah, then hope that can answer your questions. Yeah.
Thank you.
Yeah, thank you. I think yeah, that's all. So yeah, this is my email. So I think yeah, now we are applying for the DStack to be one of the CCC project, because we think like those zero trust idea, the principle, and also the ease of use property, it can really bring the values to the anyone who want to use TE, and also to the community who can like so we can increase the impact of TE over the traditional developers. Yeah. Thank you.
All right, thanks. That was a very thorough presentation. Appreciate that.
Yeah.
I will open things up to Q&A from the community, and in particular, we should try to get any clarifications that are needed for governance questions that relate to the CCC's ability to host the project.
Yeah, so a couple of questions. You did send round a document which kind of answered the questions. Do you have that available? That'd be really useful if you could if you could show us that.
Yeah, we have. So
do you know the one I mean?
You can go to docs.fala.network. Yeah, so we have a
no, sorry, I meant the set of questions from the Linux from the CCC. You answered those questions in a document and sent those to the list.
Yeah.
If you could maybe just show that on the screen so we can go through that, that would be really helpful. Thank you.
Yeah, a second, let me find it in the
sure,
email.
Dropped a link in chat to the dropped a link in chat to the mail list message so people can pull it up themselves.
Thank you.
Yeah, let me share the screen again.
Depends on where you're subscribed from. It's not always easy to find the exact message. Let me try. Yeah, Dan, it doesn't take you to the direct message. It takes you to a list of things, and you have to try and work out and navigate through to that, which I'm currently going to do.
Huh. It should take you to message.
Oh, well, maybe I'm not logged into the right thing at the right level, but it's not showing me the.
Okay. At any rate,
okay, yeah, this is the document. Optimize. So let's look at this. Let's go through this. I think that'd be a good thing to do.
Yeah.
So I think just to optimize our time, these first sections I think were already pretty well covered in the presentation that we just watched. So people can check out the project's GitHub. And one of the things that we can observe at that GitHub is that it does have an Apache 2 license. So it's copacetic with having an open license, which is one of our requirements. What else do we have here? So technical information, we just went through that in tremendous detail.
We really did, which is good.
Yeah. And so kind of scrolling through to 3.4, 3.5. So this is all the GitHub stuff. So that's all good.
Yeah.
Yeah.
Let's see here.
So is everything written in Rust basically?
Yeah. So yeah, the majority of this stack itself is writing Rust, and also we provide some SDKs for the Python,
Yeah.
Rust, JS. Yeah. So they can easily call the DStack API to, for example, get keys and generate the quote.
Perfect. Thank you.
Okay. Why don't I scroll us down to 3.9, which is the initial committers. So you've got was that five of you, and I see that.
Yeah.
And yeah, what are the affiliations of those folks as well, please? That would be.
So actually, the first four guys, we are from File Network, and Andrew Miller, he is from both like Flashbots and the Teleport.
And sorry, Flashbots and
Yeah.
I didn't hear the second thing.
Teleport.
Teleport.
Yeah, it's a new setup startup. Yeah.
Okay, cool. All right.
Okay, and Andrew is on the call, I think. So just
Yep.
double checking, Andrew, that
You're happy with this?
Yeah, that's right.
Okay.
Yeah, that's
good. And we have a Telegram. That's nice. Should carry down. So one thing we do encourage is projects to look at the OpenSSF security baseline and consider implementing that. It helps with just codifying things like vulnerability disclosures and things like that, and it shouldn't be difficult. It's a good thing.
Yeah, we're happy to do so.
Cool.
What does it reward in line 116 mean? Is it a typo with the 1111300?
I was wondering that. Yeah, what does that mean?
Yeah, I think it is some mistake, because I copied this from the it's Fala's official responsible disclosure policy. I think yeah, sorry, I made some mistake here. I need to correct it.
Yeah, no worries. Just looks like a typo, so maybe just remove the
Yeah.
111.
I think that just means from a few hundreds dollar of the reward to a higher number.
Yeah.
Shavin can correct it later on.
Yeah.
Sure. I see Paul's hand is up.
Yeah, hi. First of all, thank you, Shelvin, for the presentation. That was very interesting. Just had a question about whereabouts in the architecture you're doing the verification of attestation reports. I don't remember seeing that in the picture. Which component of the system is the verifier?
Actually, the DStack itself, it doesn't need to verify the things, except for the KMS part, because so actually, for example, before the KMS sends the keys, it needs to verify the attestation report from the application TE. But also we have an open source repo called DCAP QVL. Yeah, so this is a library which we use to verify the TDX, sorry, DCAPQVL. Yeah, this is what we use to verify the TDX, attestation report.
It's actually just a very standard decap
Yeah.
code. So all the library can be used to verify that. But the point I want to make is that we produce all the evidences for the user to run the verification, or they can outsource the verification to someone else. For example, there are some online services we run with web UI. They can submit so that it shows a verification report. And by default, user doesn't have to do that.
Okay,
Yeah, I
thanks.
think
So
this is what Han is talking about. So like actually I get my screenshots here. So you can just upload the quote here. So it will help you to do the signature verification. So it's backed by some on-chain PCCS. So which is a cache built on the blockchain. Yeah. So and it will help you to verify the signature and also break down all these fields value. Yeah, but actually this is meant to be replaced by the trust center, so the verifiable UI I was showing in the future.
But architecturally, the relying party here is what, the key management service? And do you implement the key management service and that would then have the DCAP verification built into it?
Yeah,
right.
so yeah.
okay, I'm interested in how you would be expecting to scale this to other architectures beside TDX, right? In your compatibility slide, you talked about introducing support for things like AMD 7SMP, and I guess in the future you might be looking at ARM CCA as well.
Yeah.
And I was wondering if you were familiar with the Verizon project, which is part of the CCC, which is a service that is that can perform attestation verification in a highly sort of scalable and pluggable way. And I wondered, I really just wanted to seed awareness of this project, just because it's another project that's already in the CCC. Something that already offers that scalability mechanism for appraising and verifying attestation on multiple architectures. So if you're not familiar with that project, it might be worth just going and having a look at that, to maybe test the water with it, with regards to possibly having an integration pathway between how you're verifying today with DCAP in DStack versus how Verizon might do it. It offers also sort of greater standardization in terms of how attestation results are communicated back as well.
Yeah, thank you. I haven't checked that, but yes, I think it was after these meetings was us to check it. And also, actually, we have done some simple research on the AMD SEV. So first, it's also it's also a VM-based solution. So this means like all this capability we want is there. And also, AMD did provide similar measurement register. I think it's called PCR. So it's also a level like a register of different levels which you can do verify different parts of your image there. So I think it's also provides the primitives we rely on, like the RTMR3 in Intel case, so for us to do the measurement. Yeah. So yeah, so I think there is no really like technical blocks, so that's prevent us from adopt to the AMD SEV.
One quick comment is that multi-platform support is definitely on the roadmap because there are so many people waiting for that. We started from Intel because it's just a little bit more mature compared with the others. But now I think everything is pretty good. So yeah, multi-platform and standardized attestation support is on the roadmap.
Sure. Okay. Thank you.
Yeah. Thank you.
All right. Any other questions, particularly from TAC members, that will affect your ability to bring this to a vote at the next meeting?
Did we go through all of the maintainer bits? I don't think we did. Did we just go back to the to that doc again? So one of the questions I like to ask is what plans folks have to extend the contributor base if it's mainly Fowler networks at the moment. Do you have any non-Fowler people apart from Andrew? What are your plans around that?
Yeah, I can take this question. So initially, most of the code is contributed by our team. At the same time, we're now working with. Now there is actually another contributor called Near AI. So they are not really big enterprise, but they are also a really big player in the like a Web3 world. They are going to use DStack as their fundamental layer of secure AI and privacy first AI applications. So this is one of the contributor. And now we're also talking with a few enterprise. They're pretty interested in using DStack and maybe join force to contribute. But since there's no agreement yet, and they are not contributing code yet, so we didn't list it on the slide.
Sure, that makes sense.
Yeah, I think a very overall interest is to having something similar to Apple PCC, but using the open software instead of some proprietary hardware or proprietary software built by Apple. Because most of the enterprise with user-facing AI, they are really willing to make a very comprehensive framework so that they can produce the proof. Maybe the proof can be even better than what Apple has.
Okay, thank you. Can we scroll down? Is that the last of the document?
Yeah, this is
sure. Thank you.
Okay, maybe I'll just venture one last question. So a common pattern with containers is that the containers themselves are hosted in something like Docker Hub or Quay.io, and then you're using a like a cloud native orchestration system, usually something based on Kubernetes, to actually distribute those. Does this project intend to be integrated with that style of workflow, or is the idea that the container is packaged intrinsically with your operating system image?
I got the point. So now the operating system image is just a base layer. It contains all the runtime necessary to bring up the containers, but it doesn't contain the containers. So the base layer can be shared with all the users. So we make a release and then we make a reproducible base image and release it to everyone. In this way, we can share the security because then we only need to audit the base layer. On the other side, the containers, as you mentioned, it's just distributed by any Docker compatible register, can be Docker Hub or even some private Docker registers.
And so usually to deploy things that way, you've got the OCI runtime implementations. So that's like one of the things that the too many Coco named projects. The CNCF Confidential Containers project integrates with the OCI runtime layers so that you can send those commands to start, stop, pause containers that people would expect with Kubernetes. Is that something that is in this initial scope here, or is that something that is out of scope?
I think it's in scope. So now what we have is, although we haven't, we don't have Kubernetes now, but so far what we have is we can start a container, stop a container, and update the code. I mean, like a change to another container. It's all managed by the agent running in the DStack OS. And once we get Kubernetes it will be very similar to what people can already do. Just a little bit difference is that Kubernetes is super dynamic. So we are going to have some switch. When the switch is on, you can make configuration to the Kubernetes worker or cluster. But but you cannot deploy the containers. And if you switch that off, then you can deploy the containers, but not making change to the cluster itself for security reason.
Okay, interesting. Great. All right, last call for questions from anybody, and then I will free people up.
Hey Dan and folks, this is a cool project. I also wanted to mention, along with Verizon, that it could be interesting to look at the Certifier Framework project as another way of dealing with platform independent, certification. So, just a mention.
Oh, could you share the name in the chat?
Yes, I'll put a link. I'll do that.
Nice.
I think I got there.
Thank you so much. We'll definitely take a look.
Sound look like the right URL, Chris?
Yeah, that's it.
Okay, so what will happen now is after this meeting's done, we'll make sure that the other TAC voting members who weren't present review the recording and/or the minutes. And then when we come around to the next meeting in about 2 weeks, we'll plan to bring this to a vote at that time. And I don't see any particular hangups from my perspective right now. And I would hope that if anybody else had any issues, that they would have asked them at this point.
Yeah, no, I can't see anything either. It looks interesting. It looks different. It's very much aligned with what we're trying to do. You've got plans to sort of extend how people are using things and the contributors. So it looks very positive from my point of view as well. Did we have anything else for today or not?
Just
That is it for today.
logistically, I will be in the middle of my vacation in 2 weeks. So if you want to have this vote somewhat close to the next meeting, let's just do this via email beforehand so I can like cast my vote early or something.
Excellent. Thanks for being proactive on that.
There's one other thing we need
likewise,
to
I will have vacation on the next meeting as well, I think.
We should also note that
Thanks, Paul.
this is a recommendation to the GB to accept the project, and there's a whole bunch of stuff that has to go legal alongside that as well. So it's Rian, is it worth, or Renew, is it worth starting that stuff off, or do we usually wait until we've had the recommendation from the TAC? I think we wait, don't we?
So Rian dropped off because he had to attend another meeting, and definitely
Sure.
I can kickstart the process in the back end to carry it forward. Yeah.
Okay, fine. If you wouldn't mind, that would be great. Thank you.
Yeah, thanks for the reminder on that, Mike. So just so the folks at FALA understand the overall process, once the TAC makes the recommendation, as Mike said, there's 2 other main checks that have to happen. It goes through sort of a legal audit by the Linux Foundation to make sure that you can actually donate the name of the project and the logo, if any. And usually that becomes an obstacle because nobody has copyrighted it, and so nobody really owns it. So then nobody can really donate it. It's sort of like this negative proof. So that can be a bit of a hurdle logistically, but we usually work through it. So just be aware of that. And then eventually it will go to the board, and then the board will be the ones that finally approve it. But we have to work through the technical and legal checks first.
We do. Boring, but important.
It's unfortunately terribly boring.
Unless you're a legal person, in which case you probably find it fascinating, but that's fine.
Yeah, good to
All right.
hear.
Well, thank you, everybody. Oh, go ahead.
Oh no, I just say good to hear. That's pretty straightforward, and I think we're pretty optimistic about that.
Good.
Great. All right. Well, thank you, everybody, for your
Thank you
time
very much
and
indeed,
for
everyone.
your engagement in the discussion.
Thank
See
you.
all in about 2
Thank
weeks.
you for.
Cheers.